Space-based
Space-based
solar
solar
power
power
as an
is an
opportunity
opportunity
for
for
strategic
strategic
security.
security.
Phase Zero Architecture Feasibility Study. Report to the Director, National Security Space Office Interim Assessment Release 0.1 October 10, 2007. Forward. Preventing resource conflicts in the face of increasing global populations and demands in the 21st century is a high priority for the Department of Defense. All solution options to these challenges should be explored, including opportunities from space. In March 2007, the National Security Space Office's Advanced Concepts Office presented the idea of space-based solar power, SBSP, as a potential grand opportunity to address not only energy security, but environmental, economic, intellectual, and space security as well. First proposed in the late 1960s, the concept was last explored in the NASA's 1997 Fresh Look study. In the decade since this last study, advances in technology and new challenges to security have warranted a current exploration of the strategic implications of SBSP. For these reasons, my office sponsored a no-cost Phase Zero Architecture Feasibility Study of SBSP during the spring and summer of 2007. Unlike traditional contracted architecture studies, the attached report was compiled through an innovative and collaborative approach that relied heavily upon voluntary internet discussions by more than 170 academic, scientific, technical, legal, and business experts around the world. I applaud the high quality of work accomplished by the team leaders and all participants who contributed in the last 6 months. I encourage them to continue their work in earnest as they move beyond this intro report and seek to answer the question of whether SBSP can be developed and deployed within the first half of this century to provide affordable, clean, safe, reliable, sustainable, and expandable energy for mankind. This interim assessment contains significant initial findings and recommendations that should provide pause and consideration for national and international policymakers, business leaders, and citizens alike. It appears that technological challenges are closing rapidly and the business case for creating SBSP is improving with each passing year. Still absent, however, is an appropriate catalyst to stimulate the various interested parties toward actually developing a SBSP capability. I encourage all to read this report and consider the opportunities that SBSP presents as part of a national and international debate for action on how best to preserve security for all. // signed 9 October 07 / Joseph D. Rouge, SES Acting Director, National Security Space Office. Executive Summary. Consistent with the U.S. national security strategy, energy and environmental security are not just problems for America, they are critical challenges for the entire world. Expanding human populations and declining natural resources are potential sources of local and strategic conflict in the 21st century, and many see energy scarcity as the foremost threat to national security. Conflict prevention is of particular interest to security-providing institutions such as the U.S. Department of Defense, which has elevated energy and environmental security as priority issues with a mandate to proactively find and create solutions that ensure U.S. and partner strategic security is preserved. The magnitude of the looming energy and environmental problems is significant enough to warrant consideration of all options, to include revisiting a concept called space-based solar power, SBSP, first invented in the United States almost 40 years ago. The basic idea is very straightforward: place very large solar arrays into continuously and intensely sunlit Earth orbit, 1,366 watts/m2, collect gigawatts of electrical energy, electromagnetically beam it to Earth, and receive it on the surface for use either as baseload power via direct connection to the existing electrical grid, conversion into manufactured synthetic hydrocarbon fuels, or as low-intensity broadcast power beamed directly to consumers. A single kilometer-wide band of geosynchronous Earth orbit experiences enough solar flux in 1 year to nearly equal the amount of energy contained within all known recoverable conventional oil reserves on Earth today. This amount of energy indicates that there is enormous potential for energy security, economic development, improved environmental stewardship, advancement of general spacefaring, and overall national security for those nations who construct and possess a SBSP capability. NASA and DOE have collectively spent $80 million over the last 3 decades in sporadic efforts studying this concept. By comparison, the U.S. government has spent approximately $21 billion over the last 50 years continuously pursuing nuclear fusion. The first major effort occurred in the 1970s, where scientific feasibility of the concept was established and a reference 5 gigawatts design was proposed. Unfortunately, 1970s architecture and technology levels could not support an economic case for development relative to other lower-cost energy alternatives on the market. In 1995-1997, NASA initiated a fresh look study to re-examine the concept relative to modern technological capabilities. The report, validated by the National Research Council, indicated that technology vectors to satisfy SBSP development were converging quickly and provided recommended development focus areas, but for various reasons that Again included the relatively lower cost of other energies, policymakers elected not to pursue a development effort. The post-9/11 situation has changed that calculus considerably. Oil prices have jumped from $15 per barrel to now $80 per barrel in less than a decade. In addition to the emergence of global concerns over climate change, American and allied energy source security is now under threat from actors that seek to destabilize or control global energy markets, as well as increased energy demand competition by emerging global economies. Our national security strategy recognizes that many nations are too dependent on foreign oil, often imported from unstable portions of the world, and seeks to remedy the problem by accelerating the deployment of clean technologies to enhance energy security, reduce poverty, and reduce pollution in a way that will ignite an era of global growth through free markets and free trade. Senior U.S. leaders need solutions with strategic impact that can be delivered in a relevant period of time. In March of 2007, the National Security Space Office, NSSO, Advanced Concepts Office, DreamWorks, presented this idea to the agency director. Recognizing the potential for this concept to influence not only energy, but also space, economic, environmental, and national security, the director instructed the Advanced Concepts Office to quickly collect as much information as possible on the feasibility of this concept. Without the time or funds to contract for a traditional architecture study, DreamWorks turned to an innovative solution, the creation on April 21, 2007, of an open-source, internet-based, interactive collaboration forum aimed at gathering the world's SBSP experts into one particular cyberspace. Discussion grew immediately and exponentially, such that there are now 170 active contributors as of the release of this report. This study approach was an unequivocal success and should serve as a model for DoD when considering other study topics. Study leaders organized discussions into 5 groups: 1. A common plenary session, 2. Science and technology, 3. Law and policy, 4. Infrastructure and logistics, and 5. The business case, and challenged the group to answer one fundamental question: can the United States and partners enable the development and deployment of a space-based solar power system within the first half of the 21st century, such that if constructed could provide affordable, clean, safe, reliable, sustainable, and expandable energy for its consumers? Discussion results were summarized and presented at a 2-day conference in Colorado on 6-7 September, graciously hosted by the U.S. Air Force Academy Eisenhower Center for Space and Defense Studies. Over the course of the study, several overarching themes emerged. The fundamental tasks/questions are: identification of clear targets for economic viability in markets of interest. Identification of technical development goals and a roadmap for retiring risk. Selection of the best design trades. Full design and deployment of a meaningful demonstrator. The study group determined that 4 overarching recommendations were most significant. Recommendation number 1, the study group recommends that the U.S. government should organize effectively to allow for the development of SBSP and conclude analyses to resolve remaining unknowns. Recommendation number 2, the study group recommends that the U.S. government should retire a major portion of the technical risk for business development. Recommendation number 3, the study group recommends that the U.S. government should create a facilitating policy, regulatory, and legal environment for the development of SBSP. Recommendation number 4, the study group recommends that the U.S. government should become an early demonstrator/adopter/customer of SBSP and incentivize its development. Several major challenges will need to be overcome to make SBSP a reality, including the creation of low-cost space access and a supporting infrastructure system on Earth and in space. Solving these space access and operations challenges for SBSP will in turn also open space for a host of other activities that include space tourism, manufacturing, lunar or asteroid resource utilization, and eventually settlement to extend the human race. Because DoD would not want to own SBSP satellites, but rather just purchase the delivered energy as it currently does via traditional terrestrial utilities, a repeated review finding is that the commercial sector will need government to accomplish 3 major tasks to catalyze SBSP development. The first is to retire a major portion of the early technical risks. This can be accomplished via an incremental research and development program that culminates with a space-borne proof-of-concept demonstration in the next decade. A spiral development proposal to field a 10 MW continuous pilot plant en route to gigawatts-class systems is included in Appendix B.